Hi there, welcome to this video on trig equations. This is the first one I'm going to look at a higher level. You will have looked at some National 5 equations, whether that be last year or as part of your revision before this topic. And this is just going to immediately follow on from that. What we're going to look at here is solving trig equations where a coefficient of x is greater than 1. So instead of defining sin x and cos x, finding sin 2x and cos 2x is equal to something. Solve trigonometric equations with a phase shift. So if we've got sine of x plus 30, and then solving simple quadratic trig equations as well. We're going to have a look at a couple of them, and we'll do much more practice in class. So what we're looking at is just going to be best looked at through practice, through examples and seeing what's happening, thinking about what's going on in each question. I've got 4 examples for you. I'm just going to talk you through each one. This video may be a little bit longer, but just bear with me, thanks. Okay, so first question here, and the way we're going to deal with this and these is if we only have one sine or one cos or one tangent, one trig function, we're going to just do it. This is pretty much exactly the same way we did before. Get rid of everything else around the trig function and then deal with the trig function itself. So here we're going to add 4 to both sides and then divide by 8. So it's going to be firstly 8 sine 2x is equal to 4, and then divide both sides by 8. Sine 2x is going to be 4 over 8, or a half. Now when we're dealing with the sine, getting rid of the sine there, we know we want all the solutions between 0 and 360, so we're going to be working in the first and the second quadrant. Inverse sine of a half from our exact values we know is 30 degrees. So here's where the things are a little bit different. Sine of something gives me a half. Well, I know that's going to be 30, and in the second quadrant that's 150. But the something we have here is 2x. So 2x is equal to 30, and 2x is equal to 150. Okay, those are your 2 solutions coming from each quadrant. And if 2x is equal to 30 and 150, then x has to be 15 or 75. Now that would be you finished dealing with National 5. But we want all the solutions between 0 and 360. And we know that if we're looking for a sine 2x wave, like we are here, sine 2x equals a half. A sine 2x wave has 2 waves between 0 and 360. So for equals a half, that wave equals a half here and here, which will be our 15 and our 75, but it's also here and here. We've got 2 solutions that we do not have yet. Now we also know that a sine 2x wave has a period of 180. It starts repeating after 180, and every point on that is repeated 180 degrees later. So our next 2 solutions are going to be 180 degrees later, because that's our period, and 15 and 75. So add it on to 15, 195. Add it on to 75, 255. If we could add it on again, 180, get your next solutions, but that's going to take us over this 360. And that's not something we paid a lot of attention to before, that range at the end. You're going to have to now though. Okay, so there's our solution. The first 2 coming from just straightforward. Then we have to consider our periods going forward. Next question here, first thing to notice, 0 to 2 pi. We're not dealing in degrees here, we're dealing in radians. And personally, I think it's much better to deal in radians the whole way through. It's just fractions, working with fractions, we're good at that, we can use fractions. And it means you don't have to worry about converting back at the end, and it also increases your confidence in radians. So the first thing we're doing is subtracting root 3 from both sides, and then we'll divide by 2. So cos 3x is going to be negative root 3 over 2. Look at our cast diagram, we're dealing with cos, we're dealing with a negative, so we're going to be in the second and the third quadrant. Inverse cos of a positive root 3 over 2 is 30 degrees, but I don't want 30 degrees here, I want it in radians. So it's pi over 6. Okay, so 3x here is going to be pi over 6. Oh, rubbish, it absolutely is not. We're not in the first quadrant. Apologies. It's going to be in the second quadrant. It's going to be pi over 6 back from pi, which is 5 pi over 6. Okay, if you've got a whole and you take away a 6, you've got 5, 6 left. The same in that third quadrant is pi over 6 on the pi, so it's 7 pi over 6. This is 3x, So to get x, we divide it by 3, so you have an extra factor of 3 on the bottom. So it's 5 pi over 18, and then 7 pi over 18. Okay, now we're dealing with cos 3x. We know that in a cos 3x wave, we have 3 separate waves in between 0 and 2 pi. So our answers for root 3 over 2, we're going to have 6 of them. And the period of each wave there is 120 degrees, or in this case, 2 pi over 3. So we need to add on 2 pi over 3 each time to get our repeated answers. Now 2 pi over 3 in terms of 18ths is going to be 12 pi over 18. So we're getting an extra 12 on top, so that's 17 pi over 18. 19 pi over 18. And then again, we need to add on 12 pi over 18. So that's going to be 29 pi over 18 and 31 pi over 18. Okay, so I've infringed over here, but that is all your solutions. Now we're doing exactly the same sums as you would do with degrees, but we're just dealing in fractions. And because it's fractions, we already know how to do it. Now people like to get confused here, but just take your time, work through the fractions, have some rough working beside you if you need it. Okay, but working through there, exactly the same process, be careful of your periods and move on. Okay, this one here is slightly different. We've got x minus pi over 4 in there, so it's not a double angle, it's a phase shift. But again, we've got a single trig function, so we're just going to get rid of everything and deal with it that way. Okay, so first off, let's divide by 2. So that's going to be equal to a half. Then we're dealing, next thing, this is all going to be the last thing we deal with. We need to get rid of the cos, which means we use our cast diagram. We're dealing with a positive cos, so we're first and fourth. And we'll do the inverse of a half, which is 60 or pi over 3. Okay, so this thing here has to equal in the first quadrant pi over 3, and in the second quadrant, or sorry, in the fourth quadrant, 2 pi subtract pi over 3, or 5 pi over 3. Again, just fractions, take your time with that. And then if we add on pi over 4, okay, if we add on pi over 4 to both, x is going to be 7 pi over 12 and 23 pi over 12. Okay, now this is where we have to be right on top of these fractions. We want to be between 0 and 2 pi. Okay, and that's between 0 and, because we're dealing in 12ths, 2 pi is 24. So these are both within our range. And because we're dealing with a single x, we'd be adding on 2 pi to go either side, which would take us out with our range. So that is the only two answers. Okay, and last one here. We've got a simple quadratic, and you'll look at more complicated ones after this, but single trig function, remember sine squared x, like this, really means sine x whole squared. First thing we do is divide by 4, so sine squared x is equal to root 4. If you then square root, that means sine x is going to be a half, but plus or minus a half. It could be either a half or it could be negative a half as well. Okay, and then you're just dealing with sine x equals plus or minus a half. So the way I'd approach this, if you're looking at your cast diagram, sine can be positive or negative. So actually we're going to be in all 4 quadrants. 2 for the positive, A and S, and then 2 for the negative in T and C. Inverse of a half, we know, is 30 degrees, right? We're not dealing in degrees, we're dealing in radians, so pi over 6. So my 4 solutions, pi over 6 for the first one, 180, or sorry, pi take away pi over 6, so 5 pi over 6. Pi add pi over 6 is 7 pi over 6, and then 2 pi subtract pi over 6, which is 11 pi over 6. And there's your 4 answers. Trig equations and quadratics go together really nicely. You know how to solve quadratic equations by factorising or solving like we have here. You know how to solve the kind of simple trig equations, so they go together really nicely, and we'll do lots of practice like that in class. Now, the more you experience these equations, the better you'll get. I've shown you kind of how you need to be working with them, and most of the tricks, or some of the tricks that you need to be on top of, but you'll need to do more practice to get kind of confident with it. If you need any more help with it later on, obviously give your teachers a shout. Cheers. Cheers.